Today we're going to use the optimal performance index testing system to determine the wear of a running shoe. A lot of people in the business claim that 500 miles it's time to replace a shoe, and that's not true. A shoe wear is determined by the person's weight, the amount they pronate, and the type of temperature and environment they run in. The first thing we're going to look at for determining whether a shoe is wearing is to look at the heel counter of the shoe and make sure that it is perpendicular to the plane. So you want to make sure it's centered nicely. This one's pretty well centered. The second thing you want to look at is the wear of the shoe. Of the outsole, this is pretty well worn, but it's not the complete determinant of wear. The third thing you want to look at is the structural parameter of the shoe and how it will control your biomechanics. And this will be the next phase that we're going to do. The next thing we're going to do is to test the structural parameter of the shoe and to see how it deteriorated. For us to do this, we're going to place, once we measure these parameters, into a mathematical model, and we're going to compare it to when the shoe was new and where it is now. On the mathematical model, on the left-hand side of this will be the structural parameters of the shoe when it was new. The next thing we're going to do is we're going to put the new measurements on the right-hand side of this mathematical model, and it'll tell us how much of the midfoot stability has deteriorated and how much of the rear foot has deteriorated. So the first thing we're going to do is test the midfoot. So we're going to twist the shoe to 15 degrees along its long axis, and we have approximately 42 inch-pounds of stability in the midfoot. We'll place that here into the mathematical model, and it shows that the midfoot stability has dropped 26.32%. Now we're going to test the rear foot stability, and that is calculated on the back of our index machine. We will compress the midsole under the heel to 100 pounds and find out how firm it is or how soft it is. The softer it is, the less stability. The firmer it is, the more stability. And we have a reading of 5.18 millimeters it took to get 100 pounds of pressure. We'll stick this on the mathematical model. And that shows us 19.4% reduction in rear foot stability. The overall stability of the shoe is now 60.1. So let's go to our total index schedule to see where that is now compared to when it was new. 60.1. The shoe becomes almost a moderate stability shoe. It's right in between the lower high stability and lower high stability and upper moderate stability. The shoe originally was calculated to be 70.1 index stability. So the shoe has dropped quite a bit, and we say that any part of the shoe structure that has dropped 20% or more, it's time to replace it. This shoe should be replaced. It's number one, its outsole has worn. Number two, the structural parameter has dropped tremendously. So that's how we calculate when a shoe should be